Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we will see why there is an auxiliary winding here, which is also called bias winding or VCC winding, why it is needed in primary section of any SMPS. We have a positive voltage source which is from this capacitor. It is reaching at the primary. Then the second end of primary winding is connected to this MOSFET, while we are receiving the voltage from here to VCC pin or VDD pin. Basically it is a question from one of my viewer. He asked me why two DC powers are needed for VCC of IC. Why two powers? The first power that is here, the second power that is coming from this side. He asked me one from the bridge rectifier and second from the bias winding, VCC winding or auxiliary winding. If you have not subscribed my channel, I will request please subscribe it. If this video is good, you can like it. SMPS IC. Then we have MOSFET here, transistor, MOSFET, whatsoever, and here we have positive voltage. This end is ground. How this IC will start work? This is our first question. To explain this, first of all I will say we have a bus, we have a car. To run this car we need some fuel, diesel, petrol, whatsoever. It is our first requirement for the bus. The second requirement, we need driver, and to keep activate the driver, to keep energetic, we need something to eat for the driver. There are two things. The first thing, that is the bus need fuel. Then we need a driver to drive this bus, and driver also need food. Now this is our bus, and this is the diesel, this is the petrol to this bus, and it will travel. That is the output. But to drive we need a driver. For anything which have to drive, it will need some energy. Like a driver, for example, he needs food. Like SMPS, in any IC we need a power source to power up this IC. For example, here we install a switch. We connected this winding, this switch. This is a manual switch, mechanical switch. We need someone to operate this switch. The similar here, we have a transistor here. It needs a drive on the base. To operate this switch, either it is transistor, MOSFET, IGBT, whatsoever, we need drive signal. To generate drive signal we need this IC, and to operate this IC we need some voltage source. Now this transformer does not have any power. Why? Because to generate a voltage it needs a varying magnetic field. To create magnetic field it needs switching, it needs a current flow in the winding. But this time the transistor is off, IC is off. So how it will work? To activate this IC we need some voltage source. What we do, from this voltage source which is coming from the bridge rectifier, there is a resistor that is connected here, and it is connected to this VCC capacitor. Where is that? That is here. This positive voltage, and it is reaching at pin number 7. The value of this resistance is very high. It gives a very limited charging current to this capacitor. This capacitor charges very linearly, very slowly. And in this IC there is a voltage comparator which will compare the voltage. When the voltage will reach at its specific level, at that time this IC will start switching. Before this IC was off, no signal, no life, nothing. But when it will start switching, this circuit will work. It will start to generate voltage. We have one winding, we have two windings, three windings, whatsoever. If we place another winding, The bias winding also a output winding, that is also a secondary winding, but that secondary is connected in the primary side. So its one end is grounded and its output voltage, rectified voltage, are provided here to this IC. And here we need some rectifier, some output circuit. Then there is some feedback circuit, that is optocoupler. We will not touch that circuit. We are just discussing this winding. When this resistor was providing some current, at that time this IC was off. And this capacitor will reach at a specific level. When it will reach at some specific level, at that time this IC will start switching. And it will generate voltage in secondary, it will generate voltage here. These voltage will rectified and these will start reaching to this pin. When this capacitor was charging and this IC was off, that is called soft start. At that time this IC starts slowly by reducing its duty cycle, by reducing its frequency. Different methods are used to take a soft start. First of all, for example, this was providing 1 milliampere current and this IC needs 10 milliampere for its smooth function. So initial charging current was 1 milliampere. So this resistor cannot operate this IC for a long time. In that period, when this IC will start switching, at that time this capacitor will compensate. But now when this winding started to generate voltage due to the current flow in the primary and transfer voltage in the secondaries, so we will receive voltage here. This winding is capable to provide enough current for this IC. If this winding fails to provide voltage, provide to enough current, at that time this capacitor will drop its voltage and this IC will go in off state again. Then it will wait again until the voltage at this capacitor will maintain. So this IC will keep on off. When it will maintain voltage, it will start switching. If this winding is failing to produce voltage again and again, so this action, when the level is dropped, IC will stop. It will wait until the level is maintained at this capacitor, it will start switching again. It is called restart mode or reboot mode. But when we receive a voltage here, that time this IC will start switching continuously. Now the second function of this winding. The first function, soft start, smooth running. Now we can say we need 5 volt 2 ampere from this winding. We don't have any load at that time. 5 volt, we can say 1 milliampere current, there is no load. At that time this IC is driving 10% duty cycle, slow pulses. In the result, a weak magnetic field is being produced in the primary and the voltage in secondary, and here for example at that time it is providing 8 volt. 8 volt are reaching here and it is providing enough current to this IC, so this IC will run smoothly. Now we put 1 ampere load. At that time we can say this IC started switching like this. Why? Because when we connect a load, the voltage level will drop. The feedback circuit will tell this IC that there is a voltage drop. When this voltage drop will occur, this IC will increase its duty cycle to increase more current in primary, so that the more magnetic field will build and it will give more voltage to compensate the deficiency of the voltage. Now if we can say we applied 5 volt 2 ampere load, at that time this IC started switching like this. In that case, for example, the voltage level here reached at 14 volt. When there was no load, 8 volt. When there was this load, we can say 12 volt. when we have full load, it is 14 volt. It's an example, 14, 15 volt whatsoever. This IC will become to know that there is full load. This is the maximum limit for this IC. But now if we put 5 volt 3 ampere load, that means more load, so voltage drop will occur here. It will give feedback to this IC, but this IC, when it will try to increase more duty cycle to use maximum duty cycle, at that time the voltage here will increase. For example, it will try to exceed 15 volt. When it will go to 15 volt, at that time when it will receive 15 volt, that means the overload condition is occurred now. It will receive 15 volt. Comparator inside this IC will monitor that there is a overload. So in that condition there will be overload protection. At that time this IC will disable its output to protect the MOSFET, protect the transformer output side. So we have this circuit also to monitor the maximum load current. First condition, soft start. Second condition, smooth operation. Third condition, the maximum load sensing circuit is also configured in this winding, because here we have load. To compensate the load effect, we have to increase the duty cycle. When it will keep increasing duty cycle to compensate the load, either there is a short circuit, either there is a overload. In that condition, when this IC will try to utilize its maximum duty cycle or more than maximum, at that time the voltage here will increase and this voltage will reach at this pin, that is VCC pin. In that condition this IC will go in OLP, overload protection mode. So these are the functions of this winding. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.